Hello everyone, we are group 3 from K division and today we are going to explain restoring division algorithm, which is an algorithm used by the computers to divide two integers. Now, as we know, computers cannot perform any other operation other than addition, so it only understands addition. So in order to perform the operation of division, it follows certain steps which is combinedly known as the restoring division algorithm to divide two unsigned integers. So unsigned integers are used to represent only positive integers. The algorithm converts the decimal integers into binary to perform the operation. As computers don't understand decimal integers, it only understands binary, which is 0 or 1. Now, before we move on to understand the algorithm, there are some variables that we need to understand first. The first one is A, which stands for accumulator. Then comes M, which stands for the divisor. Then Q, which stands for the dividend initially, and at the end, it stands for the quotient. And then N, which stands for the number of bits.
So from the flowchart, we can take the input as M for divisor and Q for dividend, and for output we can take Q as the quotient and A as the remainder, followed by N, which is equal to the number of bits or the counts. So to begin with, initially we'll set the value of A 0, and this process will be done n times. After that, shift A and Q towards left by 1 bit, then subtract M from A. Then the next step includes, if the sign of most significant bit of A is 1, that is negative, then assign Q0 the value 0 and restore the value of A. And if the sign of most significant bit of A is 0, that is positive, then assign Q0 the value 1. At the end, after doing this process n times, we'll finally get quotient, that is Q, and remainder, that is A, in terms of binary. And this will be explained more clearly with the help of an example.
So let's start with the example. Here we have n, m, a and q. N is the number of bits, which is 4. M is the divisor, which is the binary value, which has the binary value of the divisor, which is 3. And the binary value of 3 is 1, 1. A, which is the accumulator, is initially set to 0. Q is the dividend, and it has the binary value of 11, which is 1, 0, 1, 1. So the first operation of restoring division is the shifting left of the bits of A and Q by 1. So the result of the operation is this. So 1 goes here, this one goes here, and so on. So A has 0, 0, 0, 0, 1, Q has 0, 1, 1, and the least significant bit of Q is kept blank. So the next step is subtracting M from A, and here, as you can see, we have added the value of minus M to A. Minus M we have calculated by taking the 2's complement of M, and we have added that value to A. So the result is 1, 1, 1, 1, 0, and it is written here. And since the value of the most significant bit of A is 1, so here the blank space is filled, and since it is 1, the value of the least significant bit of Q is 0, and then the original value of A is restored, so which was 0, 0, 0, 0, 1, and it is written again here, and 0, 1, 1, 0, and the n is decremented by 1, so 4 minus 1 is 3, obviously. Next, there is again shift left of A and Q, which gives this result, and then again we have to subtract M from A, which again is we use the above method of adding minus M to A. So the value is 5 times 1, 1, 1, 0, and again there is the question mark. So since the value of MSB is 1 here, the value of LSB will be 0, and again the value of A is restored. M is again subtracted from A, so the value comes out to be 0 0 0 1 0 and 1 1 1 0 0 and again question mark. So since here the value of most significant bit is 0, here the value will be 1, and instead of restoring the value, there will be no restoring the value of accumulator. Instead of that, we'll just move on to shift left and subtracting M from A. So after performing this step, uh, the value of N is again decremented by 1, which is finally it is 0, and here in the accumulator we have 1 0, which is decimal for 2, which is binary for 2, and this is the remainder, and 1 1, which is binary for 3. It is the quotient here.
So after the example, let's discuss the hardware representation of a restoring division algorithm. Hardware representation basically means how the system looks physically. So yeah, the diagram represents how the system looks. So it consists of the control logic, which tells the operation to be done. Then there's the accumulator, then there's the divisor, and plus one bit adder, and the dividend queue. So yeah, this is it, and I hope you've understand everything. And if you have any doubts, please comment them below and like and share our video. So thank you, and these are the members of our group which have contributed to this project. Thank you.